welcome to NASA Edge.
An inside and outside look at all things NASA.
We're here at Cedar Point Amusement Park in Sandusky, Ohio.
For Physics Day.
And NASA has a big part of Physics Day.
That's right. In fact, we're going to look at one activity in particular where we've taken some data on the acceleration properties of rides, put them on a graph, and we got to match that graph with that particular ride. So it should be challenging and fun.
We have some cool microgravity demonstrations that we're going to be taking a look at today.
And you said microgravity, which is interesting because we're going to meet NASA's very own superhero, MicroGravity Man.
Hey, maybe instead of him flying in, maybe he'll free fall in.
I'm wondering if he needs a sidekick. Because I always wanted to be a superhero.
Well, we'll talk about that later. Hey, you're watching NASA Edge.
An inside and outside look at all things NASA. I would be the perfect sidekick.
We're gonna come up with a good name though. MicroGravity Man and his weightless friends. So much for Blair being a sidekick.
If I'm going to meet MicroGravity Man, I need to perform perfectly and match the data on the one side to the roller coaster or ride on the other. I wish I had brought a slide rule. Of course, then I would need to know how to use a slide rule.
Yes, we're here with Dick DeLombard from NASA Glenn at Physics Day. Now, I understand you have a little demonstration for us of some physics principles.
I've got a free fall demonstration here.
Oh, wow.
It's a very extensive NASA demonstration device here.
It looks expensive.
A couple of pieces of wood and a balloon holder.
Built from an old desk.
Yes.
Okay.
And a sharp pokey thing right there.
Okay.
But what I'm going to do is I'm going to drop this apparatus.
Yes.
And see where the sharp pokey thing comes in contact with the balloon.
Okay, now am I supposed to give a guess as to what I...
Well, where's it going to happen? When I let go it up here, or when it's in the middle, or
Probably
way down by the ground?
My guess is the ground.
So 1, 2, 3, drop. It didn't pop.
Right, but it didn't hit the ground either, so I technically would have been right.
Yes, if it had bounced off the ground and hit up, but that's the ground effect, that's gravity effect. We're talking about when it's falling during free fall.
That would have fallen forever. So,
okay. You didn't notice I took the internal force generator off.
A modification.
So without snapping anybody. Okay, now it's got an internal force to it. Okay, now when I drop it, are you going to modify your guess any for where the balloon is going to pop?
Okay, my guess is it's not going to have, it'll before it hits the ground, it'll pop. Okay. I'm just not sure where. Okay. I'm guessing like this level.
Here we go. 3, 2, 1.
Oh, well, that was much quicker.
Yes.
Yeah, okay.
Yes, it happens, if it remains out of here, it happens right away when you let it go. The internal force here takes over and pulls it closed.
More immediately.
I have a force on my hand to keep it from falling. And when I let go of that, then this internal force snaps it together like that.
That's cool.
Gravity's pulling it down all the time, but I'm pulling up on it.
You're watching NASA Edge.
An inside and outside look at all things NASA.
Which is great.
Hey, we're here with Nancy Hall, research scientist at NASA Glenn. So Nancy, tell us what you're going to be doing for us here.
Okay, well, I'm here over at Cedar Point basically to demonstrate to students what they experience on a roller coaster is similar to what astronauts experience.
Right.
Basically, if you think about it, when you're on a roller coaster, as you go over that first hill, you have this queasy feeling in your stomach.
Right.
And then as you're going down that first hill, it feels like you're coming up out of your seat. When you're falling, you're basically in a state of free fall. That's similar to what the shuttle astronauts experience.
Okay.
The only difference is instead of experiencing it for a few seconds like you do, they experience it the entire time they're in orbit around the Earth. Because they are also in a state of free fall, basically falling around the Earth. So what NASA has done is design what we refer to as our mini drop tower. Is it takes several experiments they encounter free fall. And we're able to demonstrate how things behave differently. What we have here is basically an experiment with two magnets. This top one can move up and down.
Okay.
The bottom one is fixed. If you put them together, notice how they repel.
Yeah, they repel.
So what we're going to do is put this in our drop tower and see how they behave. Usually what I do is I ask the students, what do you think is going to happen to this top magnet? There's three things it can do. It could move up, it could stay where it is, or it could move down. And usually for the students, I give them a countdown of 3, 2, 1, and then they drop.
Okay.
So let's see what happens. 3, 2, 1. Okay?
They never touched.
Yep, that's right. What you notice is the top magnet moves up. This top magnet right now is experiencing two forces. Gravity is pulling it down. The repulsion force of the bottom magnet is pushing it up. When it's in a state of free fall, the force of gravity is no longer there.
That's right.
There's only one force left, the repulsion. And that's basically what causes it to go up.
And plus they're on like charges too, so that's why they're repelling. That's right.
Yep, that's right.
Blair, did you get that? Like on like charges? We'll talk about that later. See, there's a whole bunch of cool trinkets in here. We gotta check them all out.
This other one's one of my favorites.
That's a fluid.
Yeah, that's a fluid, and that's what I am. I'm a fluid physicist, so I like doing fluid. Basically, it's in a tube. You can see the fluid liquid can go all the way around. And the question is, okay, what do you think's gonna happen to the fluid? Look at the top portion. We refer to that as a meniscus, and watch what happens.
Now the meniscus is that curved part.
Yeah,
for all your students out there.
Yeah, 3, 2, 1. What you should have noticed is while I was in a state of free fall, the ends of the fluid started climbing up the sides of the container due to what we call capillary action.
Right.
Think about trees, or flowers, when you water them, the fluid tends to climb up the sides due to capillary. That's the same thing that's happening here. All right, I have another one.
It's like a cooking scale, just a generic, okay, gotcha.
Generic cooking scale, and when you look at the cooking scale, it reads about 6 ounces here.
Right.
Hoist it up, 3, 2, 1. And if you watch the scale as it was coming down, you would see the reading on the scale went up to 0.
Zero.
Basically demonstrating, hey, when you're in free fall, you're weightless.
Well, Nancy, this is all cool stuff. These demonstrations are wonderful. I'm sure the kids are learning a lot from you.
Oh, I hope they do.
Thank you so much.
All right, you're welcome.
I'm batting 1,000 on these rides. Looks like I'm ready to meet MicroGravity Man.
Yes, we're very honored here to be here with NASA's very own superhero, MicroGravity Man. I have a couple of quick questions for you.
Oh, sure thing, Blair.
How did you become MicroGravity Man?
Well, it happened quite a few years ago. I was doing some research in our 2-second drop tower back at NASA Glen, and I was up at the top of the drop tower getting ready for one of my combustion experiments, and this sort of strange storm came up. All of a sudden, I was struck by this iridescent bolt of lightning. Sort of dazed, I went ahead and did the experiment. Going down afterwards, I hit my head on the ceiling.
On the ceiling? Going down?
Going down, and somehow I just amazingly gained these powers over gravity.
But you're now using your powers not for evil, but for good, correct?
That's right. So I'd like to help share with students about some of the wonders of science, connect them with the experiences that they feel on the rides with what our astronauts experience in space, our pilots, our research pilots on the aircraft.
What are some of the misconceptions that you generally hear from students about microgravity?
It's kind of funny. So a lot of students get the idea that as you leave the atmosphere, that gravity suddenly just disappears, and that there's this connection between air and gravity. Yet they still appreciate that gravity is what holds us into orbit.
Right.
So there's this this mental disconnect between the two, and so part of our activity here is to try to bridge that, change those preconceptions and straighten out their thinking.
Hey, you're watching NASA Edge.
An inside and outside look
at all things NASA.
Defy the laws of gravity?
That's weird.
Oh. Sorry guys, I gotta make a phone call. I'll be right back.
Where's he going?
He's MicroGravity Man.
Who, Dick?
Yeah, he's MicroGravity Man.
Nah, come on.
He absolutely is.
This is NASA Edge.
I am not MicroGravity Man. I think you'll find that there are a lot more superheroes at NASA than you're willing to admit. I'm Agent Scarn, and I'm here to talk to you about the NASA Edge Avenger Initiative.